Alright, last class we already stopped at example number 2, and we already cover one-tail test for hypothesis testing. So I hope you already watched my previous video on hypothesis testing. We are looking into hypothesis testing for one population mean, and we're going to use Z formula, right? We are using Z formula for if the sample size is more than 30. So Z is equal to x bar minus mu divided by S over square root of n. Right, this is when the population mean, population standard deviation is unknown and is more than 30, right? So when population mean is known and n is doesn't care whether n is more than 30 or less than 30, so we're going to use Z distribution x bar minus mu divided by sigma over square root of n, right? This is the formula that we already looked on the last class, right? Remember? Let's look at the, I think we already discussed on test statistics, right? So today we're going to continue. We stopped last class. We stopped at example number 2. So today we're going to continue on example number 3. So example number 3, a random sample of 100 recorded death in a country during the past year showed an average lifespan 71.8 years. So they give us a random sample n is equal to 100. From a 100 record, so we got a sample average lifespan is equal to 71.8, right? And it's also give us the information on the population standard deviation equal to 8.9. So sigma equal to 8.9. So the question is, does this seem to indicate that the mean lifespan today is greater than 70 years? So our hypothesis testing, hypothesis statement. Hypothesis statement, the null hypothesis should be mu equal to 70 and the claim is mu is greater than 70. So based on this statement, we know that we are having one tail test, right? One tail test. So sebelah mana? Sebelah kanan lah, right? More than 70, right? It should be 70, right? So next step is we need to indicate our significant level. So significant level, we are using 0.05 level of significance. So alpha is equal to 0.05. Right, and then we need to do a test statistic. Since we have n is more than 30 and we have a population standard deviation, so the formula that we're going to use is Z equal to x bar minus mu divided by sigma over square root of n. So we just plug in the value into the formula. So x bar should be equal to 71.8 minus mu is equal to 70, right? Divide by sigma is 8.9 divided by square root of 100. So this one should be equal to how much? Can you calculate for me? Can you calculate for me how much we have for what is the value of Z? Berapa? 72.8. Is it correct? Can you recalculate for me? Can anybody confirm it? So you make sure you calculate correctly. Tekan calculator betul-betul. Berapa? Semua orang dapat benda yang sama kah? 72.8? 2.022, right? Should be like this. You need to calculate carefully. Right, and next step is, since we are using test statistics, then we need to create, we need to know where is the critical region and the critical value lah. So since this is a normal distribution, so we already convert it to standard normal distribution. So mean should be equal to 0, and this is from negative infinity to infinity. The 70 should be here lah. So this is the region that we want to find. So the alpha is equal to 0.05. And the critical value here is Z alpha, this is not over 2, Z alpha, which is Z 0.05. So Z 0.05 is equal to how much? Can you look into your statistical table? Mana statistical table you? You are looking into table number 3, right? Table number 3 for Z distribution. So, sorry, it's table number 4. Alpha 0.05, it should be 1.6449. So this one should be 1.6449. And you need to note that this is the acceptance region, and this is a rejection region, right? So since we already know the acceptance region and the rejection region, then we need to create a decision rule. So if Z calculated is more than 1.6449, which is the critical value, right, then null hypothesis is rejected, right? So our decision here, since Z calculated yang mana? This is a Z calculated, right? Right, Z calculated is equal to 2.022 is more than critical value, right, which is 1.6449. Null hypothesis is rejected. So then we need to do a conclusion. So what is our conclusion? So we can conclude that since we reject null hypothesis, we can conclude that the mean lifespan is greater than 70. So we can conclude that the mean lifespan is more than 70 years old, right? So this is very simple. I think this is just a recap from the previous example, right? So now let's look at example number 4, right? So any question so far for example number 3? Do you understand? So let's look at example number 4. Example number 4, very simple. Amount spent for groceries for 25 housewives were taken randomly, right? So based on the information given, this is the information given in table number 1. Then specify the null and alternative hypothesis for testing whether housewife spend more 200 groceries and perform a test at 5% level of significance. So hypothesis statement. So null hypothesis mu, which is equal to spending for groceries, is equal to 200 ringgit. Alternative hypothesis mu is more than 200 ringgit. Very simple. So we know from here this is one tail test. So how do we know that this is a one tail test? Because the alternative hypothesis is not is more than or less than, kan? Kalau they're not equal, then it's a two-tail test. So what direction? So it's on the right direction lah. Direction on the right tail, right? So should be on the right. So next we have mean equal to 210 and standard deviation is equal to 11. So the mean and standard deviation here is taken from n equal to 25. So this is a sample standard deviation and this is a sample mean, right? So next is we need to specify our significant level. Significant level is alpha equal to 0.05. So how do we know? Because it it's asked us to perform a test at 5% significant level. And then test statistic should be Z distribution x bar minus mu divided by s over square root of n. So remember, the choice of using sigma or s is depending of the sample size and the information of population standard deviation. So this one should be 210.35 minus 200, which is, this is our mu, this is our x bar, divided by sigma is, s is equal to 11.44 over square root of 25. So can you calculate here for me? Can you calculate for me? What is the outcome for this value? Oh, sorry. Remember, just now I told you already, right? Kita ada dua option kan? When population standard deviation, right? Means the sigma is known and unknown, right? So we know these two, you are familiar with this chart, right? So if the population standard deviation is known, no matter how big the sample size, we're going to use Z distribution. So if the population standard deviation is unknown, so we look into the sample size. When the sample size is less than 30, we're going to use T. When the sample size is more than 30, we're going to use Z distribution. On this case, we're going to use T distribution lah, right? Right, T, formula for T is the same as Z distribution lah. So T equal to x bar minus mu s over square root of n. Z for this one also same, s over square root of n. Benda yang sama, but they give us a different value lah, because T require additional information such as standard deviation. So what is the answer here? One of Farahin. Are you here? What is the answer? Are you sure? Lain Nurul Aida. What is the answer? Yeah. 5236. Right. So be careful lah. Again I cakap banyak kali, be careful on tekan calculator. Right. So you make this mistake on calculator atau calculation, then you akan salah banyak dekat bawah jawapan semua akan salah. So be careful Critical region. So we know that this is a one tail test. The direction is on the right tail. Right, so the mean here is equal to 0. The is from negative infinity to infinity, and this is 4 point. So this is not a 4 point. This is a critical value. So what is the critical value? T alpha with degree of freedom. So is equal to T 0.05. Degree of freedom is n minus 1, which is equal to 24. Right. So we're going to look at the statistical table. We're going to look at table number 7. Table number 7, 0.05. Dekat sini kita tengok dekat sini, this is a 0.05. Saya tak bertulis sini Okay, this is a 0.05. 1 point. Degree of freedom is 24. So this is the degree of freedom. 24. So it should be equal to 1.711. Right? So this is 1.711. So then we need to state our decision rule. Decision rule. So if T calculated, right? So this is acceptance region. This is a rejection region. So senang nak ingat. So if T calculated lies in rejection region, null hypothesis is rejected. Sama juga dengan atas ni lah. Kalau kita nampak dekat sini, this is T calculated is more than 1.44, means that it lies under rejection region. Right? So kalau value tu fall under rejection region, so null hypothesis is rejected. This is our decision rule. Then next is our decision. So our decision is, since T calculated is equal to 4.5 is more than 1.711, null hypothesis is rejected. So next, since we reject null hypothesis, we can conclude the alternative hypothesis. So we are concluding on alternative hypothesis. So we can conclude that we can conclude that the amount of money spent on grocery is more than RM 200. Right? So this is how we construct a hypothesis testing. This is a hypothesis testing. This is hypothesis testing, and another name is what we call a significant test. Benda yang sama lah kalau kita tengok dalam different books, dia kata significant test. This is a significant test. Hypothesis testing. This is a hypothesis testing. Right? So different book, different names, different terms. Right? Now let's look at the hypothesis testing and confidence interval using Spss Output. So I hope you already have your Spss software on your machine. right? So let me show you, explain to you the output, right? Basically, this is a all output, huh? This is a all output, right? All SPSS output, right? So the new SPSS output, they have another column which is a significant one-tail test. So first, they will give you two table. The first table is one sample statistics. In one sample statistic, it will explain to us the variable that we use for testing, and this is a sample size. This is a mean of the data, right? So based on 30 sample observation, this is a standard deviation, and this is a standard error. Standard error is S over square root of n, right? And table number 2, this is a test variable, right? This is a t statistics. So t statistic is calculated based on this formula, x bar minus mu divided by S over square root of n. And this is the degree of freedom. Degree of freedom is n minus 1, right? And this is a significant test, right? This is a p-value, right? P-value, right? And this is a mean difference. Mean difference is 30 minus the test value, right? The test value is 30. 30 is mu is not equal to 30. So for the whole output, dia ada satu two tail punya p value saja kan. So this is the confidence interval, right? Confidence interval of the difference. So difference, mean difference plus minus t alpha divided by 2 n minus 1, which is the degree of freedom, and multiply with the standard error, right? Very simple notation formula. Right. To construct one sample t-test in SPSS, let's open SPSS. So you dah buka SPSS. This is my new SPSS, SPSS 28, right? SPSS version 28, I think. Yes, version 28, right? So this is, I think this is the current version. Let me see. IBM SPSS. Yep, this is a current version 28, right? So first, I think I want to demonstrate how to open a sample data. So let me open a demo data. So I hope you already have my book. So dalam buku I ada explain how to key in the data, how to construct one sample t-test, right? So I think so far none of you have shown me your proposal for project, right? So it's already week number 7. If you don't have by now your data, if you're not yet started with your project, I think it bit too late, right? So now I want to show you how to, let me close this one. Right, how to conduct one sample t-test. So let's say one sample t-test is mainly designed for numerical data. Let look into outcome. So first we need to go to analyze and go to compare means, right? And click on one sample t-test, right? So let's say I include household income and my test value. Let's say I want to claim that whether the household income is more than 80,000, right? 80,000. So and then I make sure my confidence interval or my level of significance is 0.05 lah, right? And click continue and click OK. So SPSS will give me 3 table, but actually the last table is not required, right? As a start. So now let's look at the first table. It gives us the sample size is 6,400. The mean of the sample size is 69 and the standard deviation is 78. And this is a standard error. Benda yang sama. This is a new output kan. Kalau nampak dekat sini, the difference between the old output and the new output. Right. Okay. You see? The old output, they only have significant tu dia ada dua tail saja. But the new output, they give us one-sided punya p-value. Okay? So, all are equal kan, benda yang sama. So, less than 0.01 is very small. The p-value is less than 0.05. So, now, I will show you how to read this table and conclude with hypothesis testing. So, kalau kita nampak sebelum ni, kita tengok berdasarkan t-value and degree of freedom. So, now, I will show you how to conclude your significant test using a p-value. So, since, let's say, we want to test alpha, mu is not equal to 30. So, the critical region is supposed to be on two-tail side lah, means on the right tail and left tail lah. So this is the rejection region. Rejection region. And this is the only acceptance region lah. Right. So selalu kita akan tengok, sebelum ni kita tengok based on t value. Let's say x bar minus mu divided by s over square root of n. So here they already give us 0.576, right? 0.576. So then we find the critical value based on the critical region. So t alpha divided by 2 n minus 1. So t 0.025 n minus 1 is 6. We have 6,400, right? And so this is a 30. So we have 29 here. So then we look into a statistical table. 0.05, 29 supposed to be 2.045. So this is negative 2.045 and this is 2.045. Right. So since t value is the t calculated here is lies under acceptance region, so we're going to accept null hypothesis. Null hypothesis, right? So this is based on our current understanding, right? So let me clear this one. So by using p-value, right, we don't need to state the test statistic. So let me make it in proper way. So hypothesis statement, right? So null hypothesis mu is equal to 30. Alternative hypothesis mu is not equal to 30. So alpha is equal to 0.05. The test statistic, right? So now instead of relying on the t value, so we are looking into the p value, right? So I clear this one. We are looking into the p value. So p value is, so since this is a two-tail test, we just take it as it is, 0.569. Kalau dia one-tail test, we need to divide by 2. Remember, I repeat again, if we have a one-tail test, kalau dia bagi dekat kita the old output kan. So this is the old output. Remember, kalau dia bagi satu saja, this is the old output. In case in your test number 1 nanti, right? So, our final exam, they give us the old output kan, bagi output yang lama. So kalau you have one tail test, you need to divide by 2, right? Kalau dia bagi two tail test, you don't need to divide by 2, just take it as it is, right? So if the decision rule decision rule, right? If the p-value is less than 0.05, which is our alpha, then null hypothesis is rejected. So this is the standard decision rule. If the p-value is less than 0.05, then null hypothesis is rejected. So where to get null 0.05 ni? It based on the level of significance. Remember, so if the p-value is less than 0.05, null hypothesis is rejected. So since our decision here is, since the p-value is more than 0.05, null hypothesis is accepted. Same conclusion as in T distribution, right? As in critical region, critical value punya concept. So I already taught you two concepts. First, critical region concept. Another one is p-value concept. So any questions so far? So if you don't have question, let's look at example number 5. So example number 5, a consumer research claimed that the average price pound is more than 8 ringgit per kilo during any festive season. He conducted a survey which involved 200 markets throughout country. The table 2, the table 2 here, provide the result of one sample t-test for average price pound at the wet market during first week of Ramadan last year, right? So dekat sini, kita nampak dekat sini, the test value is equal to 8, right? So maksudnya dia kata, dia claim dekat sini, dia punya claim, null hypothesis, claim always going to be alternative hypothesis ataupun alternative hypothesis, mu is more than 8, right? The null hypothesis should be equal to 8 lah, right? Right. So the claim average pound is more than 8 kilo. So null hypothesis, so sepatutnya null hypothesis dekat atas lah, tapi tak apa. But we need to understand the alternative hypothesis that they give to us. So first question is, determine the value of y. So value of y is standard error as divided by square root of n, which is equal to 0.7526 divided by square root of 200. So you can calculate this one. How much this one? Can you be faster? Faster calculate. What is the value here? So what is the value? 0. 0.0. Right. Do you get the same answer? Semua dapat sama kan? So using the information, dekat sini dia kata using the information from the output, determine the confidence interval for the average price pound. So the average price pound. So this is dia kata kat sini, this the value that we have here is dekat table the 95% confidence interval of the difference. So apa yang dia nak ini adalah 95% confidence interval for the average price. So the average price should be x bar plus minus, right? So we want to use Z distribution or T distribution here? Nurain Shuhada. You want to use Z distribution or T distribution? Z distribution, because standard deviation known. Dia tak bagi pun standard deviation. This is a standard deviation from sample. This is a standard deviation of a sample. The population standard deviation is unknown, but the sample size is more than 30. So then we use Z distribution. So it should be Z alpha divided by 2. So the confidence interval always have two-sided, lower confidence limit and upper confidence limit. So that's why we need to divide by 2 as over square root of n. So this one should be 8.9199 plus minus Z alpha divided by 2 Z 0.025, right? So since dia tak bagi tahu what is our significant level, sorry, dia bagi tahu this is 95. So Z 0.025 multiply with the standard error is 0.053, right? So you can calculate this one. So what is the value here? What is the lowest confidence limit and what is the upper confidence limit? Ahmad Faizal Tajuddin, what is the lower confidence limit? Ahmad Faizal? What is the answer? Cari dalam table lah. 0.025 should be 1.96. So you just substitute the value here lah. 8.9199 plus minus 1.96 multiply with 0.053. So what is the answer? Nadia Aiman. So kita ada 25, 24, 23 orang yang datang hari ni . Nadia Aiman, are you here? We'll take note on that lah. Okay, so next C, specify the null and alternative hypothesis for the above test. Very simple kan? So null hypothesis mu is equal to 8. Alternative hypothesis mu is more than 8 lah. Right? So it says that average prawn is more than 8 kilos. So mu is more than 8. So based on the output, is there sufficient evidence to support the researcher claim at 0.05? So we just go through test statistic. Test statistic. So we look into T distribution. Right? T is equal to 17.286, right? 17.286. And the critical value is, this one is supposed to be on the right side, kan? So the critical value alpha 0.05 n minus 1. N is equal to 200 minus 1 is 199. So why 0.05? Because we are looking into one-sided test, right? So if you have one-sided test, right, so we no need to divide by 2. So this is 0.05, 119, right? So this one should be, kalau kita tengok dalam statistical table, 0.05 T distribution, table number 4. 7. So 0.05, 119 supposed to be near to 120, right? So this is 1.658. So 1.658. So since decision rule, if t calculated is less than 1.65, sorry, is more than lah, is more than 1.658, null hypothesis is rejected. So our decision here, so since t calculated is equal to how much? 17, right? Is more than 1.658. Null hypothesis is rejected. So we can conclude that conclusion, right? So the next one is conclusion. We can conclude that the average price for prawn is more than RM 8 ringgit, right? Boleh? Muhammad Hairil, are you here? Right, good. So next, let's look at example number 6. Right, so kita tengok example number 6, 7, 8. Kita tengok sama-sama satu-satu lah. Right, until you understand. So AX Tour and Travel, after test marketing a new vacation package, right, conclude that strategy will increase its sales by more than 60,000. So it says that the alternative hypothesis mu should be more than 60,000, right? It should be more than 60,000. So now the thing that you need to be careful. So since they say 60,000, but you need to look at the statistical mean, right? The average of the sample. It says that 64,364,000. So we can use this notation, right? Kalau dia simplify, dia tulis 64.36, means that this one should be mu more than 60 lah, right? So dia dah in thousand. So this one is okay, you can leave it as it is. So this conclusion was based on recorded sales by the company agent selected for marketing trial. Table 1 and Table 2 provide result on one sample t-test. One sample test for average. Right, so determine 99% confidence interval for the average sales of the travel agency. So this is confidence interval of the difference. So average sales is x bar plus minus. So since the n is equal to 30, right? So we're going to use Z distribution, alpha divided by 2 s over square root of n, right? Remember table tadi I copy balik this one. This one is very important, you need to understand, right? So let me copy and paste here, right? So you need to always remember this table, right? When the population variance is unknown, So in this case, we don't know the population variance or population standard deviation, and is more than or equal to 30, use Z distribution. More than or equal to 30. So kita ubah sikit, tambah sikit. More than or equal to 30. So this one should be X bar 64.1293 plus minus alpha divided by 2 0. Kalau kita nak guna 99%, it should be Z 0.005, right? 0.01 divided by 2, 0.005. S divided by square root of n should be 3072.01745. So by looking at the statistical table, 0.005, table number 2, table number 4, right? Table number 4. 0.005 should be here. 2.5758. 2.5758. 3072.01745. Right? So plus minus 64,364.1293. So can you calculate for me what is the lower confidence limit and what is the upper confidence limit? Make sure you calculate correctly. So Muhammad Imran, what is the answer? What is the answer for lower confidence limit? Recalculate. Wrong, huh? Can you calculate again? Do you know how to use calculator? Right, tekan calculator pun salah macam mana ni? One or Farahin? Is it negative? It should not. It should not be negative. It should not be negative. How do you get negative? Muhammad Zul Fazli? How do you calculate the confidence interval? One Nur Farahin dapat berapa negatif tadi? Muhammad Nizam? Yes. 56451.223 lah. Huh? It's supposed to be like this. You need to know how to calculate, use calculator. This is very basic tau. Guna calculator. Takkan nak ajar kot. The upper confidence limit, Muhammad Nizam? 77027703, right? So this is a confidence interval, 99% confidence interval, right? Okay, Muhammad Imran and Wan Farahin learn how to use calculator, right? So based on the confidence interval obtained, can you conclude that the sales is more than 60,000? Is more than 60,000. So we can conclude that based on the confidence interval, we have 56,451 until 72,000, right? So 60,000 is still in the range, right? Right. So we can say that we cannot conclude. We can say that the sales can be more than 60,000 and can be less than 60,000 lah, right? You cannot conclude the sales is more than 60,000 because it can be less than 60,000 as well. So specify the hypothesis testing for the above test, right? So by looking at the statement here, it says that sales the alternative hypothesis should be more than 60,000. So the null hypothesis here is mu is equal to 60,000, and alternative hypothesis mu is more than 60,000. So this is the alternative hypothesis, right? So based on the output, right, dia kata kat sini, based on the output, state the test statistic that use, right? Is there sufficient evidence to support the claim at 5% level of significance? So the test statistic use is T statistic, right? So this is a T statistics. So T is equal T calculated is equal to 1.5, berapa tadi? 1.421. 1.421. So 421. Right? So mana kita dapat? Di sini lah. Kita ambil dekat sini. Right? So next, we need to calculate the critical value. So since this is a one tail test, we know that the rejection region is on the right tail. So T alpha divided by 2 and minus 1. So we are looking into 5% confidence interval. So T 0.025, 0.05 divided by 2, N is equal to 30, degree of freedom is equal to 29. So 29. So this one should be, look at the statistical table, table number 7. 0.025, 29 should be somewhere here lah. This is 0. Is it 2.045? This 2.045, right? So our decision rule, if kita tahu dekat sini based on the critical region, this is a rejection region and this is acceptance region. So if T calculated is lies under rejection region, null hypothesis is rejected, right? So our decision here, since T calculated is equal to is equal to 1.4 is less than is less than 2.045. Null hypothesis is accepted lah, right? So this is 2.045. So the T calculated lies under acceptance region, kan? So we accept null hypothesis. So we can say that conclusion, we can conclude that the average, they are talking about the sales is less than 60,000. The sales is less than RM 60,000. Right. So based kepada confidence interval tadi, it can be either more than 60,000 or less than 60,000, right? So here we can say that we confirm that our confidence interval says that the sales is less than 60,000. Okay, boleh? So let's look at example number 7. The staff training is very essential part of human resource management to become a tremendous significant in travel industry. Therefore, a study was done by Ministry of Tourism and Culture to investigate whether the cost spent by travel agency for annual staff training is greater than 50,000. The finding will illustrate the significance of proving staff training in industry. So this is the result. This is a T value. This is the sample size. So the question is, show that standard error is equal to 28,452. So standard error is equal to S divided by square root of N. So for the value of standard deviation is 110,273.779 divided by square root of 15. So you tekan calculator. Where is my calculator? Right. So this one should be 110,273.779 divided by square root of 15 is 28,472. 28,472. So 567. Right. So you need to show the whole thing, right? Baru you dapat markah lah. Kadang-kadang dia akan bagi standard error is not equal to 28,000. You need to make sure your calculation correct lah. So B, state 95% confidence interval, right? Of the difference in average cost spent by travel agency for annual staff training. So this is a confidence interval of the difference, right? Confidence interval of the difference. So confidence interval of the difference is this one, right? So dia kata state saja, bukan calculate lah. So state lah 14562.28 until 13667.45. Just take from here. Okay. The next question is state null hypothesis and alternative hypothesis for this study. Null hypothesis is mu equal to 50,000. Right? The alternative hypothesis, dia kata kat sini, staff training greater than 50,000. So kita tengok semua greater saja kan. Nanti kita cari yang less than. Right? So this is the hypothesis testing. Based on the p-value. So nampak dia bagi statement question ni based on the p-value. At 5% level of significance, is there enough evidence to indicate the average cost spent travel agency annual staff is greater than 50,000? So the p-value here, p-value is 0.019. So p-value for two tail test is 0.019, right? Saya tulis betul-betul lah. This is 0.019. Betul? Okay. So then if you want our problem here is for one tail test. P value for one tail test is equal to 0.019 divided by 2. So this one should be 0.019 divided by 2. It should be equal to 0.0093. Is it? 95. So 1, 2, 3. Yep. So since the p-value is less than 0.05, right, sebab kita tengok at 5% level of significance. The p-value is, this is our alpha, okay? Which is our alpha. Null hypothesis is rejected, right? So since the null hypothesis is rejected, so conclusion, we can conclude that the average cost spent by travel agency, salin balik lah, is greater than RM 50,000. Right, sebab kita reject null hypothesis, kita accept alternative hypothesis greater than 50,000. Okay? Boleh eh? Let's look at, ada soalan tak setakat ni? Don't have question. I think very simple, right? So make sure you do a lot of exercise, right? Exercise nak dapat mana? Download past year question STA 404 and try to do as much as you can, right? So example number 8, right? Views Research Corporation reported that the expenditure of university students are more than 2,000 per month, right? A sample of 15 university students was randomly selected to prove claim. The objective of the study was to create awareness among the university students on their financial management. The data was analyzed by using SPSS. So this is a degree of freedom. This is a T distribution. This is p-value, mean difference, and standard deviation. This is alternative hypothesis. So question number 1, determine 95% confidence interval of the mean expenditure. So x bar plus minus. So since we don't know the population variance, right? So this is going to be T distribution since the n is less than 30. So alpha divided by 2 with degree of freedom S over square root of n. So the average, we don't know the average, kan? Yeah, how to know the average here? So by looking at the mean difference is x bar minus x bar test. So minus mu, right? So this is the mean difference, kan? So this is the mu, right? So this is 2000 equal to 389.2287, kan? Betul? So this one sama dengan apa? It's supposed to be 2389.2287 lah. Betul? Right? Plus minus degree, kita nak ambil 95% confidence interval. So T alpha divided by 2, 0.05 divided by 2 is 0.025. Degree of freedom is 14. So looking at the statistical table number 7. So 0.025, right? And the degree of freedom is 14. Should be here lah. Right? 2.145. 2.145. And this is a standard deviation. We want a standard error. So this one should be 670 25069 divided by square root of berapa? 15 lah. Right? Mana dapat 15? We know the degree of freedom is 14 and it already says that 15 kat sini, kan? So what is the lower confidence limit and upper confidence limit? Haris Danish. Yes, sir. What is the lower confidence limit? Calculate for me. Two zero 18. Alright. 2018.02. What is the upper confidence limit? 27. Alright, good. 2760. Oops. 60.44. Right. So make sure you, alright, good, correct. So make sure you calculate correctly, tekan calculator betul-betul lah. So alternate null hypothesis and alternative hypothesis. So it claim, kita tengok claim dia dulu. Right? Always look at the claim. Right, mana dia punya color, okay. Dia kata dekat sini, reported that expenditure of university student are more than 2,000 per month. So this is one sample t-test. So mu is more than 2,000. So mu here is equal to 2,000. Right? So very simple to identify. And this is indicating one sample, one tail test. The rejection area is on the right tail, right? So this is a rejection area and this is acceptance area, right? So next is show that the test statistic is 2.249. So kita nak show this one. So test statistic x bar minus mu divided by s over square root of n. So x bar minus mu is equal to 389.2289. So divide by square root, this one should be 670.57, 25069 divided by square root of 15. Dapat tak? Kalau tak dapat, I think 89.2289 divided by 670.25069 over square root of 15. Yep. It should be equal to 2.249, right? Boleh eh? And the last question is based on the p-value in the output. So dia kata kat sini based on the p-value. Bila dia kata based on p-value means that you need to base on the p-value. Don't calculate using a critical region. Right? Jangan menggunakan critical region ni. Menggunakan p-value. So is there sufficient evidence to indicate that the student spends more than 2,000 per month? Right? Use alpha 0.05. So alpha, okay, alpha is equal to 0.05. The p-value to tail test is equal to 0.041. 0.041. So this is the p-value given, kan? So for two tail. But in our problem here, we have one tail test, right? So we need to divide by 2. P-value one tail test is equal to 0.041 divided by 2. Should be equal to berapa? 0.041 divided by 2. It should be equal to 0.0205. So our decision rule is if p-value less than alpha, null hypothesis is rejected. So this is a standard decision rule for the p-value, right? So our decision here should be, since the p-value is less than 0.05, which is our alpha, right? The null hypothesis is rejected. And then we make a conclusion lah. So conclusion. So we can conclude that the average span is more than RM 2000. Since we reject null hypothesis, we accept alternative hypothesis. Okay? Alright, let's look at the example number 9. And then example number 9, I think, sekejap. Let me look at this example. What's fun? Okay, example number 9, example number 10. Example number 10 sama saja yang kita tengok tadi. Receive a lot of comment means that more than lah. Right? Example number 11. Number of insurance also increase steadily means that more than. Right? Kita dah tengok tadi. Alright. So I will answer example number 9 dan example number 10, 11 you buat sendirilah. So based on the information given by housekeepers, it was found that the hotel was produced about 6.1 kilogram of solid waste daily. So null hypothesis mu is equal to 6.1. This is null. This is alternative hypothesis. Mu is not equal to 6.1. Right? It claimed that the hotel is produce 6.1 solid waste daily. So since this is a two-tail test, right? So the distribution will be, the rejection area will contain two-sided on the right hand side and left hand side, right? So this is rejection area, and this is acceptance area, right? So the question number one, if researcher would like to test whether the mean weight solid waste is different from 6.1 kilo, what will be the null and alternative hypothesis lah? So this is the null and alternative hypothesis, right? Right. So dekat sini dia kata based on the p-value, can researcher conclude that the mean weight of the solid waste is different from 6.1. So this is based on the p-value. So since this is a two-tail test, so kita akan menggunakan semua information ni lah. We no need to divide by 2. No need to divide by 2. So the p-value is equal to 0.00. So nampak kat sini, this is the old output presentation. Old output presentation. If you having a new SPSS, you akan nampak dekat sini dia tulis less than 0.01. Means that this number is very small. It's not equal to 0. It's not equal to 0. It's very small. The probability cannot be equal to 0. A probability of an event is not equal to 0 lah. It should be some value. Right? Kalau the probability is equal to 0, means that the event does not exist. Right? So, I hope you already know. This one kita dah belajar dalam STA 416 previously, kan? The p-value is less than 0.01. Sorry, not 0.01. It's less than 0.001. Kalau kita tengok kat sini pun, samalah 0.001. So, this is the correct presentation. Right. So, decision, if a decision rule, if the p-value less than 0.05, which is alpha, null hypothesis is rejected. So since the p-value is less than 0.05, right, very small here, kan, null hypothesis is rejected. So we can conclude that, we can conclude that the mean weight of the solid waste is not equal to 6.1 kilo. Right? Okay. Next is construct 95% confidence interval for the mean weight solid waste. So dekat sini dia bagi 95% confidence interval of the difference, right? So what we want to do is the mean of solid waste. So the confidence interval should be x bar plus minus what distribution we want to use. Kita tengok dekat sini. The standard deviation, population standard deviation is unknown. So look at the the sample size. So the sample size here is more than 30. So we're going to use Z distribution lah. Z alpha divided by 2 S over square root of N. So we just plug in the value here, right? So mean is equal to 5.2714 plus minus 95% is 1.96. Tengok dalam calculator, dalam statistical table. So this one is 1.1871 divided by square root of 35. Right? Okay. So what is the answer, Nizam? Nizam, what is the answer? Muhammad Nizam Ibrahim. 4.900. One point 642. So the proper presentation should be 4.900 mu. This is inclusive 5.642. Right. So this is the confidence interval for mean weight of solid waste. Okay. So example number 10, I think you should do by yourself, right? Example number 10 should be very simple, right? Example number 11 also simple, do it by yourself. Next class we will look into confidence interval for different of two means, right? So on this coming Thursday, Wednesday kan? Wednesday, right? Kita akan tengok confidence interval for difference. So next class will be on 25 May. Okay. Ada soalan setakat ni before we end our session? So this is, we end at 23,522. Any questions so far?